Have you ever wondered what the inside of the sun looks like? Not the glowing surface we see from Earth. I mean the real interior, the place where atoms break, where light gets trapped for thousands of years, where temperatures reach 15 million degrees. Today, we're going on a journey deep inside the sun, layer by layer, to a place no human has ever seen, but science can now explain. Welcome to the heart of our star. This is the layer we see from Earth, a boiling, violent ocean of plasma. Temperatures here reach 500 degrees Celsius, hot enough to melt every metal known to humans. The photosphere looks calm from Earth, but up close, it's full of granules. Massive bubbles of plasma the size of continents rising and falling every few minutes. Imagine standing above a sea where every wave is the size of Pakistan. That's the photosphere. Above the surface is a thin, mysterious layer called the chromosphere. Here, temperatures suddenly jump to 20 degrees Celsius. Why? Scientists still don't fully understand. This is where explosive solar storms are born, and where the sun shoots plasma thousands of kilometers into space. If the photosphere is a boiling ocean, the chromosphere is a storm of fire. Now things get weird. The corona, the sun's outer atmosphere, reaches 1 to 3 million degrees. Yes, the outer layer is hotter than the surface. How is that even possible? This mystery is one of the biggest puzzles in solar physics. But scientists think magnetic fields twist and snap, releasing unimaginable energy. This is the layer you see during a total solar eclipse, glowing like a ghostly crown around the moon. Now we dive inside the sun. Just below the surface layers lies the radiative zone, a region so dense that light cannot travel freely. A single photon, a tiny particle of light, takes 100,000 to 1 million years to escape this region. Imagine turning on a flashlight and the light only reaches your wall after 1 million years. That's the radiative zone. Temperatures here rise from 2 million to 7 million degrees. This is a silent region. No currents, no storms, just light struggling to escape through a wall of plasma. In this zone, the sun behaves like a giant pot of boiling water. Hot plasma rises, cooler plasma sinks. This constant churning creates the magnetic fields that shape the sun's every move. From sunspots to solar flares to coronal mass ejections. Every 11 years, these magnetic forces flip, causing the sun's north and south poles to reverse. It's chaos at a cosmic scale. This zone is basically the sun's engine of turbulence. Now, we reach the most extreme place in the solar system. The core. Temperature, 15 million degrees. Pressure, 250 billion atmospheres. Density, 150 times the density of water. This is where nuclear fusion begins. Hydrogen atoms smash together to form helium, releasing more energy every second. Then 1 trillion nuclear bombs exploding at once. Every second, the sun converts 600 million tons of hydrogen into 596 million tons of helium. The missing for million tons. That becomes pure energy, the energy that lights our skies, warms our oceans, and makes life on Earth possible. If the core suddenly stopped, the sun would look bright for a few million years. But inside, it would already be dead. So, what does the inside of the sun look like? A world of impossible heat. Light trapped for eons, boiling storms, and a nuclear furnace deep at the center, working non-stop for the last 4.6 billion years. The sun is not just a star. It is the engine of life, the cosmic heart that keeps our entire solar system alive. And now you know what truly lies inside it.